Thank you so much. And also thank you to Chad, Tyler, and Todd, and the whole Trace3 crew for allowing me to be a part of this. I hope you've been learning as much as I have and as much fun as I've had over the last 2 days. My name is Gene Kim. I've had the privilege of studying high-performing technology organizations since 1999. That's a journey that started for me back when I was a CTO and founder of a company called Tripwire. And our goal was to study these amazing organizations that we called high performers. They had simultaneously the best project due date performance and development. They had the best operational stability in operations. They had the best posture of security and compliance. And so our goal was always to understand how did these amazing organizations make their good to great transformation. Why would we do that? Because we wanted to understand how other organizations could replicate their amazing outcomes. And so as you can imagine, in that 18-year journey, there were many, many surprises. But by far the biggest surprise for me was how it took me into the middle of the DevOps movement, which I think is urgent and important. I think the last time that any industry is being disrupted, to the extent that our industry is being disrupted today, was probably manufacturing in the 1980s, when it was revolutionized through the application of the lean principles. And I think that is exactly what DevOps is. It is taking those same lean principles and applying it to the work that we do in the technology value stream. So in the next 40 minutes, what I'd like to do is share with you 3 things. One is a little bit about the why of DevOps. Why do I think DevOps is so urgent and important? Secondly, I want to share with you a bit of the how of DevOps. In other words, what are the principles and patterns that allow organizations to do hundreds or even thousands of deployments per day while preserving world-class reliability, security, and stability? And then third, I want to share with you what has become an area of passion of mine for the last 4 years, which is studying not so much the Googles and Amazons and the Facebooks, you know, the unicorns. It's really to study the horses, large, complex organizations that have been around for decades or even centuries, and showing how they are achieving the same almost miraculous outcomes that we've typically only associated with the unicorns. So in terms of the why of DevOps, it's really started when we started noticing in 2004 this downward spiral that regardless of whether we're a developer, a QA person, operations, or information security, left unchecked, without something like DevOps, would lead to horrendous outcomes. And it was independent of industry vertical, independent of company size, whether you're a profit or not for profit, left unchecked would lead to horrendous outcomes. And I think one of the best verbalizations of why this downward spiral occurs was framed by Ward Cunningham about 12 years ago. And he called it technical debt. Right? And specifically, he defined technical debt as it is that which we feel the next time we want to make a change. And in my mind, technical debt is almost poetic. Right? In my mind, it evokes this amazing image. It is the accumulation of all the crap that we have allowed into our data centers, each time made with a promise that we're going to fix things when we have a little bit more time. Right? But technical debt is like financial debt in that it compounds, right, without active countermeasures. So this, although bad, is not as bad as this. So what are the behaviors and activities or decisions that we make that cause technical debt to accrue in our daily work? It could be that we write code that doesn't have automated testing. It could be when we manually configure an environment. It could be when we manually do a deployment. It could be when we take shortcuts in a project and still push into production. Right? And that's a downward spiral because someone has to operate and maintain it for years or maybe even decades. But there's another downward spiral which is far less visible but far more destructive. And it is this. It is that deployments start taking longer. So think of a friend who's had an application that took 5 minutes to deploy, to an hour, to a day, to a weekend, maybe it even took a week. Right? It doesn't end there. One of the most formative moments for me was in 2007 when I got to watch a team supporting a $6 billion a year display ad business. The deployments would take 6 weeks to perform. Why? There were 1,300 steps, right, that were tedious, manual, and extremely error-prone. They would tie up 300 to 400 people, and these deployments were so problematic, they would rehearse twice a year. So this means they were either doing a deployment twice or rehearsing a deployment twice. In a given year, they're spending 30% of the time just doing deployments. And when deployments are that problematic, this is what sets the stage for the intertribal warfare that can exist between dev, test, ops, and InfoSec. So here's a friendly developer who checks in code into the source code repo at 5 p.m., right? They high-five each other in the parking lot. They start buying rounds of shots for each other at the bar, right? And they're celebrating because they made the date, not realizing they've set the entire data center on fire, right? And now ops, QA, security, and now intoxicated developers all have to work all weekend to get things running before customers notice on Monday morning. And so at this point, no one's achieving their goals. Deployments are taking longer. Features are never getting into market. We have an ever-increasing number of sub-1 outages. Operations, QA, InfoSec, we're all increasingly buried in technical debt, unable to pay down technical debt, when everybody knows that's how we can win in the marketplace. And our inability to reverse that downward spiral eventually leads to a sense of despair, right? We feel powerless to change outcomes. We even suspect that it's getting worse over time. Does anyone here have a friend that can resonate with some elements of the story? And it doesn't matter whether we're in operations, whether in development, whether we're a product owner, or even information security, right? So, the good news is your friends are not alone. And by the way, that is the first 170 pages of the Phoenix Project. It's just, our goal was to describe what does a downward spiral feel like, regardless of what functional role we are, and certainly how it feels like when we are not being served in the business. And so the good news is your friends are not alone, but the better news is that there is a better way. And how do we know that? It's because these unicorns have shown us that it's possible to do tens, hundreds, thousands of deployments per day while preserving world-class reliability and security, and they're winning in the marketplace, right? And it's not just the unicorns, increasingly it is the horses as well. Organizations that have been around for decades or even centuries who are getting the same outcomes. And so this is why I think that something really genuinely transformative is happening in the way we create things with technology. I think historians will look back 10 years from now and say, how we worked changed. And I think the label they will apply to it will be DevOps. And when they ask, where did DevOps come from, they will point universally to this presentation that was given by John Alspaugh, the VP of Operations at Flickr, and Paul Hammond, the Director of Development at Yahoo. And this was given at the Velocity Conference, where the unicorns show off the toughest dev and ops challenges, and more importantly, how they overcame them. And even in the Velocity community, this presentation was stunning, right? You had dev and ops on the same stage at the same time, right? That usually was never seen before. And secondly, they're describing how they're doing 10 deploys a day, every day, as they're part of their daily work at Flickr, right? As my friend John Willis and DevOps Handbook co-author, he said, some people were so shocked, they were throwing up in the back. And I was probably one of those, right? My reaction was, 10 deploys a day, that sounds impossible. And even if it were possible, it sounds reckless, irresponsible, ill-advised, and quite frankly, immoral. Right? Why would any decent human being do 10 deploys a day to someone else, right, when they don't need to? And I think we can say with some confidence now, after benchmarking over 26,000 organizations over 5 years, we know that the reason they do this is because it creates incredible business value. So this is work that we did with Jez Humble, Dr. Nicole Forsgren, and Puppet. So how are they high performing? We found that high performers were getting a lot more work done. They're doing 200 times more frequent deployments. That could be deployments of code or deployments of changes to the environment. And more importantly, they can execute those changes 2,500 times more quickly. In other words, how quickly can they go from a change being put into version control? And by the way, version control is not just for development. It is for everybody, everyone in the technology value stream, through testing, through deployment, so it's actually running in production so customers are getting value. High performance can do it in minutes or hours, whereas lower performance might require weeks, months, or quarters. Moreover, they're getting far better outcomes. When they do a production deployment, they're 3 times less likely to have that outage blow up, resulting in a Sev1 outage, a service impairment, a security breach, or a compliance failure. When bad things happen, they can fix it 24 times faster. In other words, it proved that so much of a common experience. In general, the larger the size of the deployment, the larger the size of the crater, right, and the longer it takes to actually fill it back in, right? So you can be faster and be more reliable at the same time. We also found last year another signal of quality. Because high performers are integrating information security objectives into every stage of daily work, they're spending half the amount of time remediating security issues. And because they're doing a better job controlling unplanned work, they can spend nearly a third more time on planned work. These are the more strategic value-added activities versus just firefighting. The last indicator of performance I want to share with you is around organizational performance. It's not just better technology performance. These organizations were twice as likely to exceed profitability, market share, and productivity goals. And believe it or not, for those organizations that gave us a stock ticker symbol, that was about 1,000 organizations, we found that those organizations had 50% higher market cap growth over 3 years, right? So these organizations are winning in the marketplace. This last year, we found yet another sort of marker of this. We found that in high performers, employees were twice as likely to recommend their organizations to their friends and colleagues, right? As a great place to work. That's as measured by the Employee Net Promoter Score. So, why is this? Why is this important? Is because not only are they managing technical debt, but it shows that high performers can help their organizations achieve all their goals, dreams, and aspirations to win. So if there's one book I would recommend to everybody, by the way, one of the things I loved about the last 2 days is how many books were recommended. So here's my recommendation. How many people here have read The Goal? Okay, so for those of you who haven't, if there's one book I could recommend, it is this. It's The Goal by Dr. Eliyahu Goldratt. It was written in 1984, and it is credited for being probably one of the biggest catalysts for lean manufacturing. It's been integrated into almost every mainstream MBA curriculum, and it's a novel about a manufacturing plant manager who has to fix his cost and due date issues in 90 days. Otherwise, they shut the entire plant down. And so if that plot sounds vaguely familiar, it should, because that's what the Phoenix Project is. We copied that entire structure. We studied that book for nearly a decade, getting ready to write that book. And one of the similarities between the two books is that they both have a Yoda, Mr. Miyagi-like character who speaks in very difficult to understand ways. And so what I want to do is share with you the 3 ways. And what the 3 ways are intended to be are the set of principles from which you can derive all the observed behaviors and patterns that you see in the high performers. That enables them to have all these amazing outcomes. So I'm going to share those patterns with you, and so hopefully you'll find them not only amusing, but potentially useful in your own daily work. So the first way is all about flow as we go from left to right in the value stream, from dev to ops. Right? And so why dev and ops? It's because dev and ops are what's in between the organizations that we serve and our customers. And so even though in the DevOps community, our favorite metric is probably deploys per day, right? We love that metric. But in manufacturing, their favorite metric is lead time. And they would probably measure lead time by how quickly can we go from a customer order to goods on the way to them, right? Or maybe raw materials at the loading dock, right, to finished goods at the other end. And would you believe that in the lean community, there is a deeply held belief that goes back 50, maybe even 60 years that says lead time is the most accurate predictor of internal quality, external customer satisfaction, and even employee happiness. And what we found in our benchmarking work is that those magical characteristics are absolutely true for the work that we do as well. And so we specifically measure lead time as how quickly can we go from a change committed to version control through testing, through deployment, so it's actually running in production. So you might ask the question, why do we start the lead time clock there? Why not earlier when, say, development accepts work, or maybe when an idea is first conceived? And it's because we believe that the point of which changes are introduced into version control is the dividing line between 2 very different parts of the value stream. To the left of version control is design and development. So the nature of design and development work is that often we're doing work for the first time. Now, it doesn't take minutes. It takes weeks, months, maybe even quarters, right? And we may never repeat it again, right? So it means the lead times are very highly variable, right? And that's just a fact of life. But everything to the right of version control is testing and operations. And there we want the exact opposite characteristic, right? We want testing and deployment and operations to be happening all the time. We want it to happen quickly, mechanistically, the same time every time. And so code deployment lead time simultaneously predicts the effectiveness of testing and operations, but it also predicts how quickly can we give developers feedback on their work. In other words, if I'm a developer and I make an error, right, if I only discover that error 9 months later when we're doing integration testing, then the link between cause and effect has almost surely been lost, right? And that's what creates blame, that creates all these bad behaviors. Our goal is in the ideal, the instant I check that change in, automated testing should kick in, and I should be notified within minutes, worst case hours, that the error was made. So how quickly can we give feedback to developers is not only important, but that needs to be quick, right? If we are only deploying twice a year, that doesn't allow us to experiment with customer outcomes, right? The faster we can iterate, the more we can out-experiment the competition. So I mentioned high performers can have code deployment lead times measured in minutes or maybe hours. In lower performers, let's call them non-high performers, it takes a little longer, right? It might take weeks, months, or quarters, because when you create a value stream map of when you initiate the deployment on the left to when you have happy customer on the right, it might take hundreds or even thousands of steps. And it's not just the number of steps, it's how many things go wrong, right? How long it takes us 2 weeks to get accurate test data. It takes us 4 weeks to get test environments that are actually configured properly. It takes 4 weeks to get security reviews, 2 weeks to get firewall changes. And I'm not saying that happens to you or your friends, but if it does, it doesn't take very many things to go wrong before you're looking at code deployment lead times measured in weeks, months, or quarters. And when you have very long lead times like that, you end up with very high probability that you have a deep sense of distrust between dev, test, and ops. Why? Because every deployment feels like a betrayal, right? It's like, you promised you wouldn't do this to me. You said that last year, and yet you're doing it to me again, right? But it's not just about hurt feelings. It's about problematic deployment outcomes. And when you look at the worst deployment outcomes of the last, say, 20 years, in my mind, it's Toys R Us 1999, Amazon 2001, Best Buy 2004, healthcare.gov. It doesn't matter what your politics are. In general, when you have very, very bad deployment outcomes, in general, is highly correlated with very, very long lead times. And one of the major reasons for this is that the first time when anyone gets to see how this entire software system behaves as a whole under production-like conditions is in the middle of the deployment, right? When we have almost no freedom to actually make corrections. And so if you believe that, I think you'll find one of the countermeasures to be very intuitive. High performers can get environments available on demand. They don't have to open up a ticket. They don't have to wait 2 weeks, right? They right-click someplace or run a command line script, and you get a production-like environment. And why is it production-like? Because the build mechanism builds dev, test, and prod. They all come from the same place. In other words, that eliminates that whole category of errors of how do you keep these environments synchronized. And believe it or not, the constituency who gets the most amount of value out of this capability is development. One of my besides developers, there's also happy end user customers. So let me share with you one of my favorite studies of how good is. It's the Facebook chat launch story. This happened in 2008, and some of you might be rolling your eyes because you're saying, it's a crappy chat server, right? Undergraduates write chat servers in their sophomore year of college when they get their computer science degree. And while that's true, what you should know is that chat is inherently, at its core, an order n-cubed algorithm. The chat functionality was actually considered to be one of the most difficult undertakings ever done at Facebook. It was the largest project team. It took them 1 year to do. So how did they use that year? Every day, the chat team would check their code into a version control repo. Whatever was in the repo would get silently migrated to production at 2 p.m. every day, right? In the middle of the day, not at midnight on Friday, where everyone has to work all weekend. So they're doing daily deployments. Secondly, would you believe that for the vast majority of that year, every active Facebook browser user session being run by those 75 million customers, they were using them as a test harness. So that JavaScript code running in the browser would send invisible test chat messages to the backend services. Why would they do that? They did it so they could simulate production-like loads, right? And they're doing this within the first month of the project, so they can find architectural errors, corrections they need to make when they have the most amount of freedom. And just to share with you where I came from, right? I consider myself an ops person, even though I was formerly trained as a developer. If you had told me, maybe 5 years ago, and asked me, is it ever okay for a developer to test in production? I would have said, absolutely not. That's crap. That's what horrible developers do to us ops people because they hate us. They're lazy, they don't care about quality, right? It's just not done. And yet, think about what a game changer it is to test under production-like loads, right, in the early stages of the project. But the other thing that's almost as important is the notion of a daily deployment. We do deployments in the middle of the day when everyone's in the office, as opposed to Friday at midnight. And to share with you why I think that's so important, this quote comes from Nathan Shimmick. He said, as a lifelong ops practitioner, I know that we need DevOps to make our work humane. In my career, I've worked on every holiday, on my birthday, even on my spouse's birthday, and even on the day my son was born. So some of you might have friends who have been in that situation. Some of you maybe are like me, who have actually created these inhumane work systems who have made people do this for years. And so when we know that there's a better way, I think we know that we have to change. We are creating inhumane work conditions. Unless you think that this is only possible for open source hippie companies like Facebook that Robert Scoble talks about, you should know about CSG. They're the largest bill printing company in the United States. If you get a paper bill from Charter Communications, a Comcast, DirecTV, chance that comes from one of the 2 CSG bill printing plants. And so their DevOps transformation was on that bill printing application. And in my mind, this is the pathological worst case of what you can do DevOps on. It runs on, a portion runs on the mainframe, a portion runs on J2EE, .NET, thin client, 136,000 desktops that support customer service reps inside of the customers. In other words, the deployment would have to, it requires 20 simultaneous technology deployments. So as part of the transformation, they went from 2 releases a year to 4 releases a year, but more importantly, they went to a daily deployment cadence, right? So what was the outcome? A year after they did this, when they do a release, incident count went down by 90%, mean time to repair went down by 98%, but most importantly, the code deployment lead time went down from 14 days to a day. So that's 14 days of the release team trapped in a war room with executives coming in, like you, saying, are we done yet? To which they would have to honestly respond, no, we're not done yet. We have 14 more days to go, right? They went from that to the deployment being finished, by 1 p.m. on the first day, right? And the Xboxes come out because there are no live site incidents. We have happy customers. We're just waiting for customer acceptance. So if you can do it for the CSG bill printing application, my claim is that you can do this for anything. And then it's great for dev, test, and operations. So the outcomes of the first way, we have everything in a single source code repository for not only developers, testers, operations, and InfoSec. It's for everybody. One of the top predictors of performance is this, is ops using version control, right? Increasingly, operations is using the same development practices and philosophies, and increasingly we share the same tools. It creates determinism, the release process. We have environments that are always synchronized. We have developers being very productive. And we are freeing ourselves from this learned behavior that deployments hurt. We don't do them at Friday at midnight, we do them in the middle of the day. And it doesn't take months, it takes minutes. And when deployments only take minutes, we have no fear doing them, right? Suddenly, we're doing multiple deployments a day, which is probably one of the most obvious hallmarks of high performers. So that's the first way. The second way is the reciprocal flow feedback as we go from right to left, right? In other words, whenever something goes wrong, how do we feed that to the earliest stages of the life cycle so that we can ideally prevent those bad things from happening? And if we can't prevent it, how do we at least enable quicker detection and recovery? And I spent a week at the University of Michigan getting trained in the Toyota production process, and I actually got to see probably the paragon of this principle, which is the Toyota andon cord, right? And the principle is how do we shorten and amplify feedback loops? And it really is true, right? In plants modeled after the Toyota production system, you have on top of every work center a cord that everyone is trained to pull when something goes wrong, right? If the parts aren't there, we pull the cord. If the parts are defective, we pull the cord. Even if the work takes longer than documented, it took a minute 20 seconds instead of the documented 55 seconds, right? Pull the cord. So what happens when you pull the cord? The entire assembly line stops, right? So that's kind of marvelous and surprising. So how many times in a typical day is the andon cord pulled? All right, just think of that number, put it in your head. How many times is the andon cord pulled in a typical day? 3,500 times a day. All right, and so when I first heard the statistic, my reaction was, these guys are idiots. These guys have no idea what they're doing. And I think that was because I was trained as a manager to buffer errors, right? Our job was to keep local errors from creating global errors, right? And it seems like the andon cord is doing something different. It seems like we're magnifying the error, right? And so when you ask the question, why would they do something so disruptive so often? Essentially what they're verbalizing is that we can't build 2,000 vehicles a day if we don't fix technical debt there and then, right? If we allow it to go downstream, it will become more expensive to fix, maybe even impossible to fix. There's also another visceral part of this answer. It would say if we don't put in a systemic fix then and there, we're going to have the same freaking problem 55 seconds later, right? So that's the notion of the daily workaround. So daily workarounds happen in our organizations as well, but because our work often takes more than 55 seconds, it's not as visible, but it is equally as destructive. And so what happens when an organization really eradicates daily workarounds as part of their daily work? I think the answer can be revealed when we look at Google. They had, in 2013, 15,000 engineers, and they're working on 4,000 simultaneous projects. In other words, they're enabling small teams to independently develop, test, and deploy value to customers without having to synchronize with hundreds of other teams. They have, every engineer is working out of one single source code repository, right? A friend of mine, he said, I'm at a large bank, and of the 93 versions of the Java struts library, we are running 91 of them in production, right? In other words, oh, by the way, all of them are insecure, right? So in contrast, Google has one version of each library allowed, right? That consistency and conformity is what allows them to do 5,500 code commits per day. They're running 75 million test cases daily. Almost every Google property deploys at least once per day. And so, you may roll your eyes and say, well, when you have 10 million servers or however many servers they have, right, that's what you do. You just run lots of tests. But I think that misses the point. Right? Why would you bother writing hundreds of thousands of tests, let alone running them thousands of times per day, right? That costs electricity, that generates heat, right? It isn't free. And I think the answer is almost poetic. Aaron Masseri, part of the dev productivity group at Google, said, it is only through automated testing that we can transform fear into boredom. He said, imagine the paralyzing amount of fear that any new engineer has when they know anytime they check in a change into version control, they can actually take down every Google property all at the same time, which has happened, right? And he said the only way that you can actually get people to hit enter, right, and not be paralyzed is by showing them this amazing safety net beneath them that will find errors long before it gets into production. And even if it gets into production, we will be able to detect it and correct for it quickly. So that gets to another pattern. Developers are put on pager rotation. I love this quote from Patrick Lightbody. He said, we found that when we woke up developers at 2 a.m., defects got fixed faster than ever, right? And Werner Vogels from Amazon says it even more succinctly. He said, if you help build it, you must help run it. And by the way, I am very well aware that jackasses like me, showing off jackass slides like this, is probably mobilizing an entire generation of developers to despise DevOps, right? They will sabotage every developer DevOps initiative, right, they see, because they will say, we did not become developers to wear a pager. Pagers are for ops people, right? The whole reason they became ops people is because they like pagers, right? And so there's an internal consistency to that logic, I agree, but I think a more compelling narrative comes from Tim Tischler. He said, as a career-long developer myself, by the way, for many years, he was running the DevOps initiative at Nike, and he said, as a career-long developer myself, the most satisfying point of my career was when I got to write the code, test it myself, push it into production myself, see the very happy customers when it worked, and see their angry shaking fists when it didn't work, and when I could fix it myself, right? I didn't have to open up a ticket. I didn't have to wait a day, right? I not only could have fixed it faster myself, but the real point is I could have learned something so I don't make that stupid mistake the next time around. And I think the observation he made was that our inability to self-test, self-deploy, and God forbid, self-fix, right, has been diminished over the last decade. And that's taken a lot of the joy out of development work, right? And ironically, paradoxically, it's actually putting them on page rotation that allows us to bring that joy back. How am I doing here so far? Is this interesting? Do you believe that? So it's great for developers, it's great for operations, and by the way, it also helps our organizations win in the marketplace. So one last pattern here is pervasive production telemetry. At Etsy, which is where John Alspaugh served for many years as the CTO, they have this culture where if you put anything in production, it doesn't matter whether you're a developer, an ops person, even security, if you put something in production, you must create around it telemetry so that you can see how it's behaving in the production environment. There's this, as Ian Malpass said from Etsy, if it moves, we graph it. Even if it doesn't move, we graph it just in case it tries to make a run for it. Right? So in 2011, they were tracking 200,000 metrics in production. That was at the feature level, application health, storage, database, OS, networking, all that, one of those metrics. In 2016 and 2015, they were tracking 800,000 production metrics. Right? The best are always getting better. And so a lot of that was enabled by this thing called StatsD and Graphite. You write one line of code, and you have one more graph. And you see these cultural artifacts in almost every high performer. So this is Rally Software, now acquired by CA. That's Tarun Reddy, the head of Dev and Ops. And right before I took this picture, someone had whispered into Tarun's ear, Tarun, the lithium crystals are fluctuating. We're down 30%. And everyone's looking at these graphs on the top. You have graphite on the right, Tableau on the left. And they know that they're not blaming each other, right? They know the issue is something between storage or database. And they know the answer is going to be revealed when you find the right graph. And what's amazing is that security people should love this. In the PCI data breach studies, they found over and over that it takes organizations months, maybe even quarters, to detect cardholder data breaches because no one's looking at the log files. How great do they feel that everyone's looking at log files every day as they're part of their daily work? And that's why at Capital One, they don't call it DevOps. They call it DevOpsSec. They're integrating all the information security objectives into everyone's daily work. So I'm going to share with you a cultural norm. DevOps people talk a lot about culture. This is called the Westrum Organizational Typology Model. What Dr. Westrum discovered 12 years ago was that the top predictor of patient safety was culture. He found in the worst performers with the worst patient safety, messengers of bad news were shot. They discouraged bridging between teams. So in his world, it would be patient intake, OR, nursing, pharmacy, outpatient care. We cover up failures. Why? Because messengers of bad news are shot. In the high performers, in the patients with the best safety, we found the opposite. Messengers are trained to tell bad news. In our world, that's like engineering at high performers. They're trained to participate and even lead blameless postmortems, right? Because high performance requires prevention. Prevention requires honesty, and honesty requires freedom from fear, right? We have to be able to tell bad news. He found that bridging between teams is required. In our world, that means InfoSec is not just InfoSec's job, just like uptime is not just Ops' job, it's everybody's job, right? And that requires shared goals and trust between those functions. So this is consistently one of the highest predictors of performance in the State of DevOps report. So the outcomes of this, everything, code reviews not just for developers. We do peer reviews for all changes. We don't rely on distant change approval boards where they're so far from the work, they really don't know whether they should approve it or not, and certainly not based on a 40-word essay in the change request form. And it's not just peer review. It comes from, we get assurance from automated testing that runs all the time, just like at Google. We have proactive monitoring of the production environment so we can detect and correct issues quickly. And by doing that, defects and security issues are being fixed faster than ever. We have a high trust culture. We know how to communicate and coordinate. And the end effect is that we're all getting more work done. Small teams are able to develop, test, and deploy value to customers without having to take everybody in the organization out to lunch, right, and get approvals from 43 different committees. So the first way was flow, left, right. The second way is feedback, right, left. And the third way is fostering this norm of a culture of high trust, continual experimentation, and learning. I think one of the people who's embodied this the most in the technology community is Adrian Karl. He's famous for many things, but I think one of the things he's most famous for is the work that he did at Netflix, migrating the video delivery infrastructure back in 2008. In 2008, would you believe that the video delivery infrastructure was a monolithic J2EE app that ran in a private data center, right? And so over years, they migrated, so it was running entirely in the public clouds. And so one of the philosophies was we have to do painful things more frequently. And I think one of the best evidence of the effectiveness of this practice and philosophy was on April 22nd, 2011. This is the first global Amazon EC2 failure. All of AWS East went down. And so basically every customer went down, except for a couple curious exceptions, the most curious being Netflix. So everybody was asking, what is Netflix doing differently that caused such a different outcome for them? The leading theory was, well, even back then, Netflix is Amazon's largest customer. Clearly, they had a friendly salesperson that gave them a special feature flag that said, do not crash, right? And I was a scrub to that theory. The real answer was revealed some days later after that outage. And in this seminal blog post that they put out, they revealed two design decisions they made very early on, back in 2008. They're the following. One is they said we can have no single point of failure risk, of which the largest is Amazon. Right? They said we can almost guarantee they will never be there when we need them most. Two is they said, in order for us to survive failure, we're going to have to fail all the time. And that's when they unveiled the now famous Chaos Monkey. And Chaos Monkey, of course, is this audacious piece of code that runs on every production service, and it randomly kills compute instances. Right? And you can imagine how quickly they got good at recovering when it's randomly doing that in production. So there's three things I want to share with you that Adrian doesn't talk about, but you really should know them. One is, before you run Chaos Monkey in production, run it first in test. Right? They did. Two is, don't run. Did you know that Netflix only runs Chaos Monkey during office hours? Right? You don't want to do it at 2 a.m. and waking people up. Drills happen in the middle of the day as part of our daily work. And three is, did you know on that day, April 21st, 2011, Netflix went 6 hours into the EC2 outage before declaring a Sev1 incident. Right? In other words, every hour they would assemble the tech leads and say, do we declare a Sev1? And to which they would always respond, no, it'll come back. It usually does. Only 6 hours later did they say, holy cow, maybe it's not coming back. Maybe we should activate some business continuity procedures just in case if it doesn't come back. Right? So the reason why I share this story is that the reward for caring about availability so much that we actually inject faults into the production environment is that what it was chaos and confusion for everybody else was just a normal day. So the one practice I want to share with you is that this doesn't happen automatically, right? We have to aggressively pay down technical debt. This is a gentleman named Marty Kagan. He's trained a generation of product owners on how to build great products. And one of the things that he put in his awesome book called Inspired is this one phrase: every product owner, you must take 20% of all engineering cycles off the table. Those cycles are not for you. That's for the engineers to use however they best see to fix problematic areas of code in the environment, to refactor, to re-architect, to automate, right? And the reason he believes that is that he learned that lesson when he was the VP of product management at eBay. He said, if you don't pay that 20% tax, you're going to inevitably pay 100% tax because he didn't ship a new feature for nearly 2 years because the entire engineering team was spending all their time just trying to keep the site up, right? So if we can go to a situation where it looks like this, that inevitably turns into this, right? If we can create the collective will to solve that problem, a coalition of that willing who want to see how good life can be, that's how we can get to here. Incidentally, this is a picture of the Reston, Virginia data center at VeriSign. This is like a $60,000 cabling job. What Ken Silva said is, when you are running the single point of failure for all of .com, right, you don't blink an eye to pay that price. And so in the same way, you as technology leaders shouldn't blink at paying a 20% tax because that is what it takes to create world-class services and a world-class engineering organization. So the last thing I want to do is share with you is what has been my area of passion for the last 4 years, which is studying not so much the unicorns, but the horses. How are large, complex organizations adopting DevOps principles and practices and getting the same sort of amazing outcomes that we typically only associated with Google, Amazon, and Facebook? And so that's the reason why I've been holding a conference called the DevOps Enterprise Summit for now going into the 4th year. And the goal was to get technology leaders from large, complex organizations to share their story. Tell us about your industry. Here's how you compete. Here's where I fit in the org chart. Here's the business problem we set out to solve. Here's what we did. Here's what worked, what didn't work. Here's the problems that still remain. So I just want to share with you some of my favorite stories. One is Heather Mickman, Senior Director of Development at Target. The business problem that she set out to solve was every time a dev team wanted to get access to the systems of record, right? Product information, product catalog, store information, shipments, cross-shipments. They would often have to wait 6 to 9 months for the system of record teams to get ready, right? Because everything was tightly coupled, point-to-point integrations. They put everything into a next generation, what they called the API enablement project. It was using Cassandra, Hadoop, Redis, but more importantly, they used versioned APIs. So any developer, any team could add, change, remove data, on demand. They didn't have to wait 6 to 9 months. That is credited for enabling 53 different business initiatives over 3 years. Topo Pal at Capital One, now an engineering fellow, he described how by building a shared service, they're enabling teams across the Capital One enterprise to do deployments, hundreds of deployments per day, with lead times measured not in months, but in minutes, safely and securely. Gary Groover talked about they went from doing 1,500 tests at Macy's every 10 days to hundreds of thousands of automated tests being done daily. Jason Cox, over the years, he's embedded hundreds of ops engineers directly into the lines of business, into the dev teams, helping them be as productive as if they were at a Google, Amazon, or Facebook. Nationwide Insurance, they did this for a COBOL mainframe app, the State Pension Retirement Fund application, of which they were already the market leader, right? They were #1, and they still did this. So, all of these, I think, should give you confidence that DevOps principles and patterns apply to everything, right? It's not just open source, hippie companies like Facebook. The second thing I want to share with you is the courage being displayed by these people driving these transformations. I got to shadow Heather Mickman for a couple of days. This is 2 years ago. And I noticed on her desk there was a certificate. And it says, it looks like it was printed in like Print Shop Pro or whatever we use these days. And it says, Lifetime Achievement Award for Annihilating TEP and LARB. Right, so what is TEP and LARB? TEP is the technology evaluation process. That's a form you have to fill out whenever you want to do something that's never been done before. And that will eventually earn you the right to pitch to the LARB meeting, right? The Lead Architecture Review Board. You go into this meeting, you have all the dev architects on one side, all the ops architects on the other. They pepper you with questions, they start arguing with each other, and then they get assigned 50 more questions to answer, come back next month. And her reaction was, why are we doing this? Right? None of my engineers should go through this. And she told me, no one could really remember, just like someone said yesterday, right? It's the way we've always done it, right? There was some vague memory of something very, very, very bad that happened about 16 years ago, but no one could actually remember what it was. And so 9 months later, they annihilated TEP and LARB, earning her this amazing certificate that is proudly posted on her desk. So I think there's actually a term for these kind of behaviors. It's called transformational leadership. And I want to share with you what those are. One quadrant is inspirational motivation. Can you see the business goal and how we can get ahead of it, especially from a technology perspective, and not only align, but get others on board? Is a leader exhibiting idealized influence? Can they set an example, set the conditions for lifelong learning, both for themselves as well as for their team? Individualized consideration. Can they coach, guide, and enable? These are a lot of things often suggested by servant leadership, right? And I love this last one, intellectual stimulation, right? This relentless need to challenge status quo. No matter how long we've done it, we've got to do it better, especially in an age where everything's being disrupted, and in order to win in the marketplace requires us how to change how we work in technology. So we tested the presence of this in the State of DevOps report, and in a couple weeks we'll share with you the amazing results. Leadership does matter. So why do I think this is important? It's because the downward spiral happens everywhere. Left unchecked without something like DevOps leads to horrendous outcomes. It doesn't matter if you're leading managers or developers or testers or ops people or security, right? Without things like DevOps, results in horrendous outcomes, not just for the functional silos, but ultimately dooms the organizations that we serve. And I think the value of doing this is, I would express like this. IDC, the analyst firm, says there's about 8 million developers on the planet, 8 million operations people on the planet. I think the goal is to get every one of those 16 million engineers as productive as if they were working at a Google, Amazon, and Facebook, right? The value is not going to get created in the unicorns. The value will be created in the horses, and I think that's really the mission at hand. Thank you for Trace3 for making the DevOps Handbook available. And my fellow DevOps Handbook co-author, John Willis, will be presenting this afternoon at 2:30 about DevOps, Docker, and a whole bunch of other stuff. So thank you again for allowing me to be a part of the Trace3 conference. And if you are interested in these slides, all the videos and slides of the DevOps Enterprise Summit talks, as well as a whole bunch of other stuff, all you have to do is send an email to realgenekim@sendyourslides.com, subject line DevOps. By the way, don't take a picture. Just pick up your phone, send an email to realgenekim@sendyourslides.com, subject line DevOps, and you'll get an automated response within a minute or two. So thank you so much. Have a great remainder of your day.